Elsa Calio from Sanchez Mira, Cagayan, Philippines. And before we proceed to our presentation, may I just take this opportunity to shout out some important individuals. First, our SDS of Cagayan, Dr. Orlando Manuel Seso 5, our district supervisor, Dr. Silvino Sidayao Jr., and of course, the two public high school principals. Here in Sanchez Mira, we have Dr. Harry B. Collado of Sanchez Mira National High School and Dr. Ronald B. Gapusan of Sanchez Mira School of Arts and Trades. My co-teachers, our students who are also with us into this session. I hope they will participate and answer our questions later. Actually, this is our present topic in Mathematics 9 and it's very relevant and timely. Okay. Our first topic is triangle and its different types. So how do we define a triangle? A triangle is the smallest polygon with the following characteristic. It has three vertices. Example, we have vertex A, vertex B, and vertex C. It has also three sides. That is side AB or side BA, side BC or side CB, and side AC or side CA. Next characteristic, we have it has three angles. So we have angle A or angle BAC or angle CAB, angle B or angle ABC or angle CBA, angle C or angle ACB or angle BCA. And if we are going to add the interior angle of the triangle, we have a total of 180 degrees. So if we draw a diagonal of a quadrilateral, the diagonal will form two triangles. It is not necessarily that the diagonal will divide the quadrilateral into two congruent triangles. So since there are 360 degrees, the total interior angle of a quadrilateral, so we have to divide it by 2 so that one triangle in the quadrilateral will have 180 degrees. Okay. Now we can classify triangles according to their sides and according to their angles. Types of triangles based from their sides. So can you name the first triangle, this one, the green one? It is the Iscalene. No sides are equal. How about the second one, the red one? It is the Isosceles. So two sides are equal. So if this side, can you see my cursor? If this side measures 8 meters, therefore its congruent side also measures 8 meters. And then the last one is equilateral triangle. So the prefix equi means equal, lateral means side. So all the sides are equal. So if one side measures 8 meters, the other two sides would have 8 meters also. Okay. How about types of triangles based from their angles? So we have also 3. Can you name the first triangle, the green one? It is the acute triangle. All angles measure less than 90 degrees. So for example, we have your 30, 70 degree, 80 degree triangle. Next, we have your right triangle. One angle measures 90 degrees. The sides that form 90 degree are called the legs. They are perpendicular with each other. And the side opposite to 90 degrees is the hypotenuse. It is the longest side of the triangle. And then the last one would be the obtuse or obtuse. One angle measures more than 90 degree. Okay, example, we have 30 degree, 50 degree, 100 degree, triangle that is obtuse triangle. Okay. Next topic, we have congruent triangles. Congruent triangles, the vertices of the two triangles correspond in the same order as the letters naming the triangles. So, for example, we have here two triangles. Wait. Here. Okay. So, we have your vertex A corresponds to vertex D, vertex B corresponds to vertex E, and vertex C corresponds to vertex F. So if you name the first triangle as triangle ABC, then the second triangle should be triangle DEF. Or if you name the first triangle as triangle BCA, then the second triangle should be triangle EFD. The correspondences of the vertices can be used to name the corresponding congruent sides and angles of the two triangles. So let's name the correspondence. We have sides. Side AC corresponds to side DF and they are congruent. Side AB corresponds to side DE and they are congruent. Side BC corresponds to side EF and they are congruent. That is corresponding sides. How about the angles? We have angle A and angle D are corresponding angles and they are congruent. Angle B and angle E are corresponding angles and they are congruent. Angle C and angle F are corresponding angles, therefore they are all congruent. We have also CP, CTC. Corresponding parts of congruent triangles are congruent. So, two triangles are congruent if and only if their corresponding parts are congruent. Example, okay, so I will give you 15 or 20 seconds to answer the problem. You have to name the corresponding congruent sides and angles and name the congruent triangle. Okay, 20 seconds. Okay, let's check your answer. Corresponding sides, we have your side AD corresponds to side FD and they are congruent. Your side AB corresponds to side FE and they are congruent. Side BD corresponds to side ED and they are congruent. How about the angle? Angle A corresponds to angle F and they are congruent. Angle B corresponds to angle E and they are congruent. Angle A, DB corresponds to angle F, DE and they are congruent. So if you name the first triangle as triangle A, DB, then the second triangle would be triangle FDE. Properties of triangle congruence. We have 3. Triangle congruence is reflexive, symmetric, and transitive. So, reflexive, for any triangle ABC is congruent to triangle ABC, or simply your A is congruent to A. Next, symmetry. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. So it's like saying that your A is congruent to B then B is congruent to A. Next, we have the transitive. It involves three triangles. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. It's like saying that your A is congruent to B and B is congruent to C. Therefore, your A is congruent to C. Third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So in here, your angle A is congruent to angle D. Angle B is congruent to angle E. Excuse me. Now, your angle C should be congruent to angle F. Why? Because if we are going to add this angle A and angle B and subtract it from 180 degrees, the difference would be the measure of angle C, which is also the measure of angle F. Okay? Proving that triangles are congruent. I have here an example. So given side AD is congruent to side CB, side DC is congruent to side DA, angle ACD is congruent to angle CAB, angle CAD is congruent to angle ACB, and we have to prove that these two triangles ACD and triangle CAB are congruent. So the first statement would be side AD is congruent to side CD, side DC is congruent to side BA. That is given. Next, side AC is congruent to side CA. You just imagine. Okay? You imagine the figure. That is because of reflexive property. Number 3, angle ACD is congruent to angle CAB, and angle CAD is congruent to angle ACB. That is given. Number 4, angle B is congruent to angle D because of the third angles theorem. Therefore, the two triangles, triangle ACD and triangle CAB, are congruent because all corresponding parts are congruent. We also have definition, postulate, conjectures, and theorem. What is a definition? Can be written as a biconditional statement that contains the wording if and then. Example, if two coplanar lines have no point of intersection, then the lines are parallel. That is the definition of parallel lines. When we say coplanar lines, lines that lie on the same plane. Next, we have the postulate, a rule that is accepted without proof. Example, if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. It is a parallel postulate in Euclidean geometry. It is assumed to be true and there's no need to be proven. But that is under Euclidean geometry. In the modern geometry, there were oppositions and they consider curves as lines. Conjectures is an unproven statement that is based on observations. Example, if you are given 3 points in a plane, then you can connect them to form a triangle. You cannot connect 3 points that are collinear to form a triangle. When we say collinear points, points that lie on the same line. Theorem is a statement that can be proven. Example, if two lines are cut by a transversal, so that alternative interior angles are congruent, then the lines are parallel. This is a theorem. It is the alternate interior angles converse theorem. How about the difference between the axiom and the corollary? When we say axiom, it is a statement consisting of self-evident truth. It is accepted as true even without proof. Example, or yes, the whole is greater than its part. Your full body is greater than your hands, is greater than your head, right? Things that are equal to the same things are also equal to one another. So those are examples of axiom. How about the corollary? A statement that typically follows that a given theorem. For example, if two sides of a triangle are congruent, then the angles opposite these sides are also congruent. That is the definition of isosceles triangle. And then, every equilateral triangle is also equiangular triangle. In two-column proofs, the statements in the reason column are almost always definitions, postulates, or theorems. Proving that triangles are congruent using postulates and theorems. We have the SSS postulate or the side-side postulate. If three sides of one triangle are congruent to the corresponding sides of the other triangle, then the two triangles are congruent. Example, we have your triangle ABC and triangle DEF. So if AC is congruent to side DF, if side AB is congruent to side DE, then side BC is congruent to side EF. So as you can see, the lines here denotes that they are congruent. Therefore, your triangle ABC is congruent to triangle DF by the SSS postulate or the side-side-side postulate. Okay, so I will give you again another 20 seconds to answer the problem. Which triangles are congruent based on the markings in the given figure? Okay, let's check. Side GR is congruent to side ER. Side GT is congruent to side EA. Side TR is congruent to side AR. Therefore, triangle G TR is congruent to triangle EAR. Did you get it? Okay. Next problem, we are going to prove the two triangles. So we have the first column are statements, the second column are reasons. First, side AB is congruent to side CD because it is given. And then side AD is congruent to side CB. Again, it is given. Number 3, side BD is congruent to side BD. Reflexive property. Therefore, your triangle ABD is congruent to triangle CDB because of the SSS postulate. Next, the SAS postulate or the side angle side postulate. If two sides and the included angle of one triangle are congruent to the corresponding two sides and the included angle of another triangle, then the two triangles are congruent. Okay, so here we have your triangle ABC and triangle DEF. If side AC is congruent to side DF, and angle A is congruent to angle D, those are included angles, and side AB is congruent to side DE, therefore your triangle ABC is congruent to triangle DEF by the SAS postulate, or the side angle side postulate. Okay, another proving. We have number 1 statement, side AB is congruent to side DE, that is given. Angle A is congruent to angle D, given. Side AC is congruent to side DF, given. So side, angle, side. So triangle ABC is congruent to triangle DEF through the side angle side postulate. Next, the ASA postulate. If two angles and the included side of one triangle are congruent to two angles, and the included side of another triangle, then the two triangles are congruent. Example, we have angle A is congruent to angle D, and side AC is congruent to side DF. Angle C is congruent to angle F. Therefore, triangle ABC is congruent to triangle DEF by the ASA postulate, or the angle side angle postulate. Another proving. So first statement, angle B is congruent to angle D, given. AE, or line segment AE, bisect BD, that is given. Number 3, BC is congruent to DC. Definition of bisect. And number 4, angle ACB is congruent to angle DCE because they are vertical angles. Therefore, we forgot to write, therefore, your triangle ABC is congruent to triangle. Oh, I think that's wrong. That should be triangle DEC. Okay, kindly check this one. That should be triangle DEC. Okay, because of the angle side angle postulate. Next, the AAS, or the SAA theorem. If two angles in a non-included side of one triangle are congruent,